Broadly speaking, there's 8 types of correlations, only 4 of which are actually causal. And we'll cover them one by one. The first type of correlation is causal, where a variation in variable x is causing variation in variable y. What do I mean by variation? Let's suppose that the variable x represents the variable years of education, and the variable y represents the variable wages. What this graph is saying is that some variation, or change in years of education, causes some corresponding variation in wages. If the correlation is positive, then that means a positive change in years of education causes a positive change in wages. In other words, more education causes greater wages. And equivalently, less education causes less wages. The arrow is what's going to denote the cause and the effect in the relationship between two variables. So here, the arrow is pointing from x to y, which means that some variation in x causes some variation in y. If there is no arrow, we should note that there is no causal relationship, perhaps just correlation if there is any. The second type of correlation is also causal, where a variation in variable y is causing variation in variable x. Note that this is just the opposite case of direct causation. Let's call this reverse causation, since now it's variation in y that is causing variation in x. This is denoted by the arrow which points from y to x. An example of this type of correlation is the relationship between debt levels and economic growth, which has been a highly debated topic for some time now, in regards to the direction of the causal relationship. On one side of the debate, we have an economist like Carmen Reinhart, who believes that high debt levels cause slow economic growth, and on the other side we have an economist like Paul Krugman, who believes that it's slow growth which causes debt levels to rise. The third type of correlation is also causal. Let's call it simultaneous causation, where variation in x and variation in y cause each other in a continuous feedback loop. For instance, if a student's motivation is high, they are more likely to learn, but if they succeed at learning, their motivation will rise. And the cycle continues. The fourth type of correlation is not fully causal, but still causal in the traditional sense of the word causal. In everyday life, causation is transitive, that is, if x causes y, and y causes z, we are usually prepared to say that x causes z, but only through the channel y. This is also called indirect or chain causation. As an example, a burglar intrudes into the home of Sally, setting the alarm on. The alarm causes Sally to wake up. The burglar causes Sally to wake up, but only through the alarm, for it's the alarm that actually wakes up Sally, not the burglar. What's interesting with indirect causation is that any information about the burglar becomes unnecessary to say what happens to Sally if the status of the alarm is known. In other words, z is independent of x, given y, or put it a more familiar way, whether the burglar intrudes into Sally's home is irrelevant to the status of Sally once we know whether the alarm rang. If we know the alarm rang, we know Sally wakes up. If the alarm didn't ring, we know Sally is sound asleep. What the burglar does, doesn't matter once we know the status of the alarm. Let's now talk about the types of correlations that are not causal. And we can visualize this by there not being an arrow between variables x and y. The variations in x and y are caused by something else, namely the variation in variable z. And we know this because there are two arrows pointing out from z to variables x and y. So the representation tells us that there is a causal relationship between z and x, and z and y. But our focus will be on the association between variables x and y, which is not causal. An example of this type of correlation between x and y is the recent U.S. tariffs against Chinese aircraft tires and rail parts. Whether there is a tariff imposed by the U.S. on China is represented by variable z, and the sales of those two products, aircraft tires, and rail parts, which are both affected by the tariffs, are variables x and y. So what the graph tells us is that the changing status of the tariffs causes variation in sales of Chinese aircraft tires and rail parts. More concretely, tariffs imposed on China causes both Chinese aircraft tires and rail parts sales to go down. And the absence of a tariff conversely causes both Chinese aircraft tires and rail parts sales to go up. This means that there is a positive correlation between Chinese aircraft tires and rail parts sales. They move together in the same direction. But note that this spurious relationship between Chinese aircraft tires and rail parts exists solely because of the common variable tariffs, which actually has a causal relationship with both aircraft tires and rail parts sales. It's not that Chinese aircraft tires have any causal effect on Chinese rail parts. In other words, decreasing Chinese aircraft sales do not cause Chinese rail parts sales to go down. Tariffs do that. And conversely, Increasing Chinese aircraft sales do not cause increasing Chinese rail parts sales. The elimination of tariffs do that. And we know this fact because we observe the value of variable z, whether there is a tariff in place. But when we do not observe z, we become blind to the true cause of the variations in x and y, the sales of Chinese aircraft tires and rail parts in this case, and find ourselves believing x and y to have a causal relationship. We'll discuss this z variable more later in other modules, but for now, just take note that z is called a confounding variable because it confounds or obscures the true relationship between x and y, which we mistake for a causal one when z is not observed. The sixth type of correlation is also not causal, and this is due to equivalence. X and y are equivalent. Therefore, they exhibit perfect correlation. If the temperature is 0 degrees Celsius, then it is 32 degrees Fahrenheit. One doesn't cause the other. It is just another way of referring to or describing the same thing. They will be perfectly correlated, and certainly not because of causation. The seventh type of correlation is also not causal, and we visualize this by there not being an arrow between variables x and y. But there is an arrow between variables x and z, and variables y and z, which means that variations in x and y both cause variation in z. So there is a causal relationship between those two pairs. But our focus will be on the correlation between x and y, which is not causal. An example of this type of correlation between variables x and y is a car's battery status and tank status, which affect whether the car starts. Let x be a variable that tells us whether we have a working battery, let y be a variable that tells us whether there is gas in the tank, and let z be a variable that tells us whether the car runs. In this example, knowing that the battery is charged means nothing about whether there is gas, but knowing that the battery is charged, and that the car won't start, means that the gas tank must be empty. What this example is showing us, is that while battery and gas tank status are independent variables, they are nevertheless made dependent and correlated, when the common effect, whether the car runs is known. The variable z is called a collider variable and it's what induces a spurious association between two parent variables, x and y, that don't cause each other, and share no common cause, but are made dependent through the common effect they cause. The last type of correlation is also not causal. We call this a coincidence, which is best exemplified by examples from Tyler Vigan, a management consultant, who had maintained a blog about coincidental correlations. This example, the divorce rate in Maine correlates with the per capita consumption of margarine. Hopefully, you are convinced that this is pure coincidence. Another example, number of letters in winning word of script's national spelling bee correlates with the number of people killed by venomous spiders. Again, pure coincidence.